There are four basic concepts of electricity: current, voltage, resistance, and power. Current is the movement or flow of electrical charges. Current is electrons in motion. The conventional symbol for current is I. The ampere, often shortened to amp, is the SI unit of electric current. It's named after André-Marie Ampère, French mathematician and physicist, considered the father of electrodynamics. Voltage is the potential difference between 2 points, or the difference in electric potential energy between 2 points. Voltage is the pressure that pushes the electrons and causes them to flow. The conventional symbol for voltage is V. The volt is the SI unit for electric potential difference, and electromotive force. It's named in honor of the Italian physicist Alessandro Volta, who invented the voltaic pile, possibly the first chemical battery. Resistance is the interference to flow of electrons or the opposition to the flow of charges. Electrical resistance is conceptually similar to mechanical friction. The conventional symbol for resistance is R. The ohm is the SI unit of electrical resistance. It is named after German physicist Georg Simon Ohm. Power is the rate at which electric energy is transferred by an electric circuit. The conventional symbol for power is P. The SI unit of power is the watt, named after the Scottish engineer James Watt. The relationship between voltage, current, and resistance is known as Ohm's law and is the basic foundation for all circuit analysis in electronics. Ohm's law states that the amount of current I is directly proportional to the voltage V and inversely proportional to the resistance R. Expressed mathematically, Ohm's law is stated as I equals V divided by R. If the value of V and I are known, then to find R, V is divided by I. Similarly, if V and R are known, then I is found by dividing V by R. If I and R are known, then V is found by multiplying I by R. In this circuit diagram, the value of the resistance is not known. The applied voltage is 12 volts, and the current flow is 4 amps. To find the value of R, simply divide V by I, or 12 by 4. The value of R is 3 ohms. When the value of the applied voltage is not known, but the amperage and resistance are, you can find the value of V by multiplying I by R, or 6 amps times 4 ohms, and the answer is 24 volts. When the value of the current is unknown, we can find the value of I by dividing V by R, or in this case 12 volts divided by 3 ohms. The value of I is 4 amps. To calculate power, the current flow in the circuit is multiplied by the EMF or voltage, so P equals I times V, or watts equals amps times volts. In a circuit, if we have a battery voltage of 18 volts and a lamp resistance of 3 ohms, we can use Ohm's law to determine current. 18 volts divided by 3 ohms equals 6 amps. Now that we know the current, we can take that value and multiply it by the voltage to determine power. 6 amps times 18 volts equals 108 watts. Similarly, based on Ohm's law, we know that current equals voltage divided by resistance, so we can say that power equals the current, voltage divided by resistance, times the voltage, or voltage squared, divided by resistance. If we don't know the voltage, but we have the current and resistance, we can use Ohm's law to find the power. We know that voltage equals current times resistance, so power equals current times resistance, or stated another way, current squared times resistance. The power then equals 6 amps squared times the resistance, 3 ohms, yielding 108 watts.